AI connection. Lesson 2. In this lesson, I will go over narrow AI, also known as weak AI or artificial narrow intelligence, ANI. Weak AI refers to AI systems designed to perform specific tasks or a set of closely related tasks. Unlike general AI that aims to replicate human intelligence across a wide range of activities, narrow AI is limited in scope and functionality. I will go over general AI later. Narrow AI refers to artificial intelligence systems designed and trained to perform specific tasks or solve particular problems. Unlike artificial general intelligence, which would have the ability to perform any intellectual task a human can do, narrow AI is limited to a well-defined area of expertise. Narrow AI is the type of AI most commonly in use today and powers many of the applications we interact with daily. Here are some of the characteristics of narrow AI. It is task-specific. Narrow AI excels in one specific function or a limited range of tasks. It doesn't possess general intelligence or reasoning abilities beyond its programmed function. It will have predefined goals. Narrow AI systems are created to achieve preset goals. For example, a facial recognition system has one goal: to accurately identify faces in images. There is no self-awareness. Narrow AI lacks consciousness, emotional intelligence, or self-awareness. It cannot learn or adapt beyond the scope of its programming without additional human input or retraining. It is highly accurate in specific domains. Despite being weak, narrow AI can achieve human-level or better performance in specific tasks such as translation, game playing, or medical diagnostics. Here are some key characteristics of narrow AI. It is task-specific. Narrow AI is built to handle particular tasks such as facial recognition, language translation, or playing chess. It excels in these areas but cannot perform tasks outside its programming. It uses predefined rules. These AI systems operate under a set of predefined rules and algorithms. They do not possess the ability to think abstractly or understand context beyond their programmed domain. Data-driven. Narrow AI can analyze large data sets quickly and accurately, identifying patterns and making data-driven decisions. However, its learning is confined to the parameters set by its algorithms and the data it processes. Here are some of the applications of narrow AI. Narrow AI is pervasive across industries, powering technologies we encounter every day. 1. Virtual assistants like Siri, Alexa, and Google Assistant are all examples. These voice-activated assistants use narrow AI to understand spoken language, answer questions, set reminders, and control smart home devices. They rely on natural language processing to understand and respond to user queries. 2. Recommendation systems like Netflix, Spotify, and Amazon use AI algorithms to recommend content or products based on user preferences. These recommendation engines analyze massive amounts of data to make personalized suggestions for users. 3. Autonomous vehicles, such as Tesla's autopilot, use narrow AI to analyze sensor data, detect obstacles, and make driving decisions. These systems are highly specialized, focusing on tasks like lane keeping, object recognition, and navigation. 4. AI-powered facial recognition systems, such as those used in iPhone's Face ID or security systems, are designed to detect and match human faces to store data for identity verification. 5. Narrow AI is used in healthcare to analyze medical data and assist in diagnostics. For instance, AI models are used to detect cancer in radiology images, diagnose conditions based on symptoms, or suggest personalized treatment plans. 6. Tools like Google Translate or Grammarly use a specific form of narrow AI called natural language processing, NLP, to process language, translating text or suggesting grammar corrections based on predefined rules and training. 7. Industrial robots and automation systems often operate using narrow AI. For instance, robots in manufacturing are programmed for tasks like assembly or quality control, performing repetitive processes with precision. 8. AI systems like DeepMind's AlphaGo or IBM's Deep Blue are narrow AI agents that have mastered specific games, Go and chess respectively. These AIs are optimized to outperform human players in their respective domains, but cannot generalize to other tasks outside of their game environments. Some of the strengths of narrow AI include efficiency. Narrow AI can perform specific tasks faster and more efficiently than humans, especially when processing large amounts of data. Accuracy. In many domains, narrow AI systems achieve greater accuracy than humans, particularly in tasks involving pattern recognition, like medical imaging or fraud detection. Cost savings. Narrow AI automates repetitive and data-driven tasks, reducing the need for human labor in many industries, such as manufacturing, customer service, and logistics. Some of the limitations of narrow AI include limited scope. Narrow AI cannot operate outside its specific domain. A system designed to recommend movies, for example, cannot suddenly start diagnosing medical conditions without extensive retraining. Lack of generalization. Narrow AI lacks the flexibility of human intelligence. It can't transfer knowledge from one task to another, even if the tasks are related. Each application requires a different AI model and training. Dependent on data. Most narrow AI systems rely on large data sets to train their algorithms. If the data is incomplete, biased, or erroneous, the AI's performance will suffer, leading to inaccurate predictions or unintended consequences. No adaptability. Narrow AI can't adapt to new or unforeseen situations without reprogramming. It operates strictly within the rules and models created during its development, and doesn't learn beyond that without intervention. While narrow AI is widely used, its implementation has raised various concerns. 1. Ethical issues. AI used in areas like facial recognition or law enforcement raises ethical questions about bias, privacy, and surveillance. For example, facial recognition systems have been found to have higher error rates in identifying people of color, raising concerns about fairness and equality. 2. Job displacement. Narrow AI is automating many jobs, particularly in manufacturing, retail, and customer service. This automation raises concerns about job displacement, as AI takes over tasks traditionally done by humans. 3. Security. AI systems can be vulnerable to manipulation. For example, adversarial attacks can trick image recognition systems into misidentifying objects, which can have serious implications, especially in autonomous vehicles or security systems. 4. Bias. AI models, especially those trained on biased datasets, can perpetuate and even exacerbate social biases. This is particularly concerning in systems that make decisions about hiring, credit approval, or criminal justice. Future of narrow AI. While narrow AI is powerful and pervasive today, researchers are also working toward developing artificial general intelligence, AGI, which would be capable of performing a wide range of intellectual tasks beyond narrow applications. However, AGI remains in the realm of theory, and significant advancements in AI research are needed to achieve it. Narrow AI, on the other hand, will continue to evolve and improve, with advancements in areas like transfer learning, explainability, and ethics to make these systems even more efficient, trustworthy, and aligned with human values.